in this problem, we have n cards, and each of these cards has some number I on it. And then we're given m operations that we can do, in which we're given two integers b and c, and we can choose at most bj cards, and then we can change some number in the list to cj, right? And then at the very end, we want to find the maximum possible sum of any m cards in this list. Okay, so let's break this down, right? So this is the list where we first have, and then we can choose at most bj cards, which means we don't even have to choose any cards, and then we can change some card with some other card value cj. So when do you want to change some card into cj? So if let's say some ai in this list a is less than the value of cj, then if we change ai with cj, then the overall sum of the list becomes bigger, right? But which ai do you choose? And the best ai to choose would be the smallest in the list. So if you just find the smallest element in the list and we check, hey, is this bigger than cj, then we swap it. Then we find the newest smallest element in the list, and then we keep on checking and checking, and we do this bj times. And then if the smallest element is suddenly the same as or bigger than cj, then we stop and then we move on to the next to the next operation. Okay, so but if we actually do this process of one by one changing through each operation, we will have a issue with time complexity, because this is only two seconds. Oh wow. Okay, so let's think about what this question really means, right? So at the end of the day, we'll just keep on switching cards if there's a card that has a value that's larger than any card, right? So in the end, all we want is the m largest cards from what we start off with and then what we add on. So if we just add all these values to a map and we find the m largest cards in this map and we add them all together, that should be enough. So there's no need to find the max after each operation. We can just do it at the very end in one big go. Okay, so we're given n and m. So okay, and then we're given the a. So we could store it in an array, but as of right now, we just want to keep count of the number of each element we have. So let's just create a map from long to long called map, in which the first value will be the number that we see. So like ai, like a1, a2, a3, and then the second number will be the number of times we have this number, right? So yeah, and like here we'll have 1 5 1 4 1 5 1 1 and 1 4, right? And then we'll add 2 3s, right? And then we'll add 1 5 to our map, and then afterwards we'll just see what are the 5 biggest elements that we have. Okay, so then how big is the list again? It's n. So for n, let's just read in some long x, and then the map will increase the value of x by 1 because we see one entry of x. So that handles this line. So now we get b entries of some number c. So then we'll do for m, we're given, let's say, just keep everything as longs, b and c. Let's read them in, and then we'll do mp of c plus equals b. And this has to be plus equal because there is a chance that we see a c in the list of a in above, right? So at this point, we have now we have track of what elements we've seen and the number of times we've seen these elements, right? So now what we can do is we go order iter equals map.end. So now we're at the very end of the map, and then we can just keep on going through the map until we have seen the n largest elements, right? So okay, so while ends. So we'll keep on making the value of n 1 less when we add. Okay, so for our answer, let's just have a long called answer, right? So we'll start. So as we know, a map is in order, right? So the value, so the largest value will be at the very end of the map, right? And that's what we want, because that will increase our sum by the most. So we look at the very last element, right? And then, so first and foremost, which ans plus equals iter dot first. Yeah. So we want to. I just call the number and the count, right? The number of times we've seen the number. So we want to increase the answer by the number, and then we decrease count by 1, right? And then we do iter. Actually, we can just do if yep, iter dot second is 1, which means this is the last time we have this number with us. Then we can just say mp dot erase iter, because we won't need that with us any more, right? And then if that's not the case, then we'll just do what was it, mp of iter dot first, and we want to decrease this value by 1. Minus n, and then we'll just out. Okay, does this work? Let's find out. Oof, guess not. So we start at the very end. Actually, we do not want to decrease it every single time. We always want the very last element. Copy this, run D14. This should be 338. Finally, this should be 1001. Okay, it works. So to clarify what we just did, we store all the numbers that we've seen and the number of times we've seen that number into some map. And all we want to do is find the m largest numbers. So since the map is in order, what we do is we look at the very end of the map to find the largest element. And then we see, so then we add that largest element to our sum. And then if we do see it again, we will just decrease the count by 1. And if we don't see that number again, we just take the largest element out of our map, and then we go to the next largest element. And then we always increase our answer by the largest element. And we do that n times because our list is of size n. And this should be good. And voila.